but now they'll say type C. You won't see proprietary or improved type X. It'll be just say type C. Method 4 is a comparison method, and the IBC allows the determination of fire resistance ratings based on a comparison of building element, component, or assembly designs having fire resistance ratings as determined by the test procedures set forth in ASTM E119 and UL 263. The combined with the provisions of IBC 104.11 listed in item 5 allow the building official to approve a design that complies with the intent of the provisions of this code, and that the material method of work offered is, for the purpose intended, at least the equivalent of that prescribed in the code in quality, strength, effectiveness, fire resistance, durability, and safety. Method 4 was basically used in developing the research report SRR number 1509-02, which is the calculated 2-hour fire endurance assembly. And here's a kind of a color of what that, or colored illustration of what this looks like. That assembly has a fire rating of 2 hours and a finish rating of more than 90 minutes. Now, finish rating is a term that's used to describe the protective membrane, which in this case would include these 3 layers of type 5/8" type C gypsum. And in order to get a 90-minute finish rating, those 3 layers acting together, they're thermocouples that are during the fire test that are installed at various locations in this, or along the assembly and within the assembly. And the finish rating typically is you're looking at 2 things: the any one thermocouple, the ambient temperature, or excuse me, the temperature at any one thermocouple located basically at the interface between that inner layer of, or the uppermost layer of the gypsum in this case, and the bottom of the truss cord. Any one thermocouple at that location cannot increase in temperature more than 325 degrees above its ambient temperature when the test started. So if it started at 70, it can't increase the temperature at any one thermocouple at that interface cannot increase by more than go up more than a temperature of 395 degrees. And then on average, all the thermocouples in that assembly at that interface can't increase more than 250 degrees above the ambient temperature. So again, if you're interested in the 2-hour calculated method, and there are 2-hour tested assemblies as well, but I would refer you, for the calculated assembly, I would refer you to the 1509-02 SRR report. The comparison method is based on Harmathy's 10 rules of fire endurance rating. We won't take the time to go through that during this presentation, but if you're interested in more information, I would suggest you consult sections 4-13 from the Society of the Fire Protection Engineers Handbook for more information. Method 5, like we said, is then alternate methods and materials. It's allowed in the building code. And the highlighted and bold at the bottom of that paragraph, and I won't read it for you, but basically you can see that fire resistance is one where alternate materials, design, and methods of construction are permitted. So the alternate materials and methods allows for other methods of developing a design by an approved source that complies with the intent of the code, and unless it can be demonstrated not to comply with the code, should be approved by the building official. And then, as I said before, in the latest and greatest version of the IBC, the 2015, assemblies are also allowed if they are approved or certified by an approved agency. So in conclusion, as far as fire-rated assemblies are concerned, the building designer must submit to a code jurisdiction a fire resistance rated design that incorporating metal plate connected wood trusses using any of the 6 methods allowed in section 703.3 of the IBC. If it's not a listed design, the building designer should submit details regarding how the submitted design was determined and show how it complies with the intent of the building code. For the truss manufacturers that are on this call, this is obviously outside the scope of what you're doing unless you're involved in design build. This is not something that you're going to get involved with. However, knowing this information, I think you can certainly help out your customers, certainly by helping them with the documents that SBCA offers, by having a copy of the this SRR 1509-01. When you get a set of construction documents and where it's specifying rated assemblies, certainly if it's a tested assembly, you can then go and look and see, well, what's kind of the basics of that, and then make sure that your truss designs are going to meet the requirements in terms of the minimum depth and maximum on-center spacing and so on and so forth. And if not, you can obviously bring that to the attention of your customer and or the building designer. Some of the reference documents that are used in or cited in the report are listed here. We've talked earlier about the National Building Code of Canada, again, as a great source for many of the, or for several additional prescriptive assemblies involving metal plate connected wood trusses. And again, as I said earlier, if you end up going to the our website and download a copy of the report, the links in the report are hot. So in other words, every one of these that are underlined in red should take you to directly to that website or to that document.